some detailed part of the recurrent neural networks. And at the end, I will try to connect this recurrent neural network to LSTM, connect the LSTM to the transformer model, and directly we will talk on the different applications where we can use the transformer based models. So when we are talking about the generative AI, so our topic is generative AI. So in this name itself, it is giving the some meaning to us, like generating some artificial intelligence, right? So what kind of generation? Okay, what kind of data it generate? Like as he can generate the text, he can generate the audio, he can generate the video. So this is a generative AI. Normally, when we are talking about the AI, when we are talking about the AI, I hope everyone is already familiar with this diagram. When we are talking about the AI, the main aim of AI is to give the knowledge to the machine, which can take a decision like as a human, which can think like as a human, which can behave like as a human. So this is the main aim of artificial intelligence. And to achieve this objective or this aim, okay, we are using the number of techniques, number of technologies, number of models, right? So best example to understand AI is robot, okay, or self-driving car, to understand the example of artificial intelligence, who can behave like as a human. In self-driving car, okay, without driver, that car can, okay, run on the road, can take a decision based on the some environment, like as a traffic is there, accident is there, red signal is there, no one present on the road. So based on these different scenarios, based on these different kinds of environment, agent is taking the action. Okay, and it is like as a, this is similar as a human. So when we check the performance of self-driving car and okay, human car, so it is almost similar, right? So this is the best example to understand the AI. But to take an intelligent decision like as a human, like as a brain of that car or brain of that robot, okay, is nothing but the machine learning. Okay, and we train this machine, okay, with some examples, like as what is the machine learning. Okay, machine learning, okay, based on some examples, we have examples, and we are giving the training to my machine with the examples, past experience, and based on these examples, based on this training, I'm improving the performance on particular task. So this is the machine learning. And when we are talking the brain of this artificial intelligence, or brain of that robot is the machine learning. So the till date there are number of algorithms are present, like as more than 5,000 algorithms are present, okay, to give the training to that machine, like as a supervised machine learning algorithm, unsupervised machine learning algorithm, semi-supervised machine learning algorithm, reinforcement learning algorithm. The number of algorithms we are using to give the training, okay, to that machine. But in that we can say deep learning are the some set of the algorithm. Like as if I'm talking about the regression task or the classification task, support vector machine or random forest, okay, decision tree. Similarly, neural network is the one algorithms, and deep learnings are the some set of algorithms. Okay, so we can say that this is a subset of machine learning. This is a subset of machine learning. So when we are talking about the machine learning and deep learning, yes, number of algorithms in machine learning, but in number of algorithms, deep learning are the some set of algorithms, right? So there are some advantage of deep learning, and today we are giving the more focus on the deep learning algorithm. When we are talking about the generative AI, when we are talking about the large language models, when we are talking about the transformer based models, all that models are under this category. Which category? Deep learning category. Deep learning category, right? So today first we will give the more focus on the deep learning, and then we will try to touch on the different generative AI models, right? And everywhere we are using the data science. So data science is not our part, but where is the deep learning? You should know, right? So indirectly we are saying deep learning is a part of machine learning, and machine learning is a part of artificial intelligence. So let's start with the basic. Okay, my role is to give the knowledge about the from basic, okay, introduction part of the generative AI. So if you are interested to do the some task in generative AI or large language model by using the large language models, yes, definitely you must start with the simple theory. What is a neural network? Because when we are talking about the generative AI, transformer based models, okay, his base is neural network. Okay, all these models are extracted or expanded, okay, on this neural networks model, right? Try to understand. So if you are talking about the transformer, you must understand the neural network. So my first model, I will start with the basic theory of the neural network, basic theory of the neural networks, right? Because when we are talking about the large language model, why it is important? Nowadays every application is generating large amount of data. Every model is every application is generating large amount of data. So definitely we required a such technology, which required a different technology which can handle this large amount of data. And when we are comparing the trends, when we are comparing the trends of the deep learning trends with the traditional trends, definitely deep learning is giving the better performance. When we are checking the performance of different winning architecture of ImageNet competitions, you can see from last 2012 to 2020, all winning architectures are based on the neural network. So definitely era is changed from the 2012. And uh, also we can see the trends, okay. In this graph also you can see after 2012 the deep learning trends is changed. Deep learning trends are changed, okay. From in today's world, hardware is not a problem. In today's world, hardware is not a problem. What is the problem is we need to write a one software, we need to write some program which can handle this large amount of data. This is a challenge, right? So when we are talking about the renowned personality in this neural network, Geoffrey Hilton is there, or who invented the Jan LeCun? Jan LeCun invented the convolutional neural networks, or Andrew Ng, we know that he is the founder of machine learning. These are the renowned personalities, okay, in this deep learning. So let's start with the deep learning and machine learning. I hope you are familiar with the some basics of the machine learning, because I am trying to connect with directly neural networks. So prerequisite of this session is you should know about the some basics of the machine learning. You should know the some concepts on the different mathematical concepts, as well as you should know the some basic on the different, how we can train the model, how we can write the code in Python or other languages. So when we are comparing the machine learning and deep learning, in machine learning, yes, machine learning is useful to give the training to the machine based on the past experience, but as a part of pre-processing, the major task is we need to extract the feature first, and then give these features to the machine, and then machine can train. Okay, we can start with the training. So main headache, okay, is based on the feature extraction. But in deep learning there is no need to extract the feature. This is a very important difference between the machine learning and deep learning, okay, where deep learning is don't require the features, but it requires the features, but it is not extra model to extract the features from the input data. Okay, deep learning algorithms automatically can extract the features from the inputs, right? So this is a big advantage of deep learning, and remaining theory is same. But so why deep learning is so popular? Because okay, deep learning algorithms are capable to extract the features, not only features, hidden features. Sometimes human also cannot extract the that hidden features, but machine can extract that hidden features. So that is the beauty of deep learning algorithm. When we are talking about the Andrew Ng one paper is based on the recognition of cat and dog in 2012, and Renji implemented this application where okay, when the half part of that images is also there, like as if dog is there and his half part is not seen and his half part is visible. Based on this half part also, the machine can able to extract the features, and based on that features, machine can say which dog is there in that image. That is the beauty of deep learning, right? So this is the basic difference between the machine learning and deep learning, right? Why we are going towards the deep learning? Because in previous diagram also we have seen, when we increase the data, deep learning algorithms, deep learning algorithms performance of deep learning algorithms is increase, and when we increase the size of the data, traditional machine learning performance is decrease, right? So deep learning, why we are using the deep learning? We need to handle large amount of data, first thing, and we need to extract number of features. Okay, we know that if I want to classify something, if I want to think, okay, give the decision like as human, in that case, okay, I need to consider the number of parameters, different parameters. And if I want to consider all these parameters to give the training to my machine, definitely I need to think differently, and this thinking is available in the deep learning. Okay, so what is deep learning? Okay, I hope you know this definition. Deep learning, okay, these are number of layers are there. Like as a deep learning, okay, what is the deep? So we are giving the training in depth. We are giving in depth, like as okay, I will give you the simple example. uh, when we enter into the one classroom, we can see the number of objects simultaneously, we can recognize the number of objects simultaneously. I can say this is a fan, this is a tube, this is a table, this is a laptop, this is boy, this is a girls. So I can see one image, but simultaneously I can recognize the multiple objects, right? So how I can recognize this multiple object? Based on the some theory. Which theory? This theory is given by the Dr. Hubel. Dr. Hubel is given the theory human can okay, see, concentrate on the pixel. When he combine the pixel, he can check the edges. When he check the combine the edges, he can see the part of object, and when he combine the part of object, we can see the full object. So this is the theory is given, layered theory is given by the Dr. Hubel, and based on that theory, okay, we can recognize, okay, the multiple objects simultaneously, right? So similar kind of theory we are trying to include in deep learning also. So this is the main concept of the deep learning, and we know that everywhere we are using the deep learning. I'm not going into the detail, but you can just see the different applications. Okay, like as a security application, like as a agriculture application, in smart city application, in every hackathon we can see the different applications are there where we can use the deep learning. Okay, deep, if data is like as image, if data is text, if data is audio, and the data is video, like as the multimedia data, so everywhere we can apply the deep learning, everywhere we can apply the deep learning. But there is also some limitation, we will talk the limitation at the end of this session. But why we are using the deep learning? Number of applications are there nowadays in other part of the smart city. Okay, I am from the Pune city, so I know that in my Pune now different applications are trying to develop or using as a part of the smart city. In smart city, okay, or like as a vehicle type classification, or like as a, some anomaly detection, Okay, on the road, he want to detect some speed. Different applications are there. For the traffic intelligence system, they can use the deep learning. They can use the deep learning. So number of applications are there. Like as the latest application, just I want to share, like as the chat GPT, everyone is familiar with the chat GPT. Number of similar application, like as the Gemini is also there. Number of applications, similar applications are there. We are using the chat GPT. Right. Nowadays, when I want to create something, I want to create something like as okay, I don't have a time and I want to send a important mail to my director. How I can write? So just I can give the some important okay sentence to my some commands like as, and he understands this command and he is giving the whole email. Or I don't have a time to check the grammar in that text. That machine is automatically check the grammar, right? So he is giving the whole email. Or when I am typing something, he is predicting next word. Like as a, when I am saying the please find the attachment, so when I'm typing the please, the internet is giving the remaining word. Please find the attachment, right? So he is predicting the next word, and whatever the word in my mind, the same word is predicting that machine. So that is the beauty of generating text, right? So there are number of interesting applications nowadays which we are using nowadays. And in machine translation, like as another application is machine translation. The number of applications are there where we can use the deep learning, right? Latest application self-driving car is also there where we can use the deep learning. So number of applications are there where we can use the deep learning. Now, before going in the detail in the neural networks, detail going into the neural networks, this is the generalized steps for the machine learning. Okay, what we need, data, we need divide this data or we clean this data. This is the machine learning model, not deep learning model. Okay, we need to clean the data, we need to divide this data into training part and the testing part. By using the training part, training data, I can train the model. By using the testing data, I can train, okay, test my model. And if the performance is not as per my expectation, I need to retain the model. So I can improve the model. So these are the generalized steps for the machine learning, how I can train. Now, if you are aware about the basic models of the machine learning, now directly come towards the some supervised machine learning models. In supervised machine learning models, we know that labels is already there, and by using that labels, we are giving the training. Okay, label is already there, and by using the labels, I can I can give the training like as I know the, okay, I know the labels like as a x, I pass this x through the functions and I'm predicting the y. Okay, I'm predicting the y. So whatever this x is there, whatever this x is there, whatever this x is there, this is my label samples are there, right? So in supervised learning, we can say regression task is there, classification task is there. I am not going into the detail, but I hope you are familiar with the regression task and classification task as a part of the supervised learning. And in unsupervised learning, clustering clustering tasks are there or association tasks are there, right? We are talking about the supervised learning, which is the most important category of machine learning. In supervised learning, there are a number of algorithms are there, like a support vector machine, like as a decision tree, like as a random forest, and like as a neural networks. So neural network algorithm is not new in the market. Try to understand this algorithm is present in the part of the machine learning. But when NVIDIA launched the GPU in 2008, and when the Alex proposed one architecture to own the ImageNet competition in 2012, after that era change. And when the another era change in 2017, when one paper came like as a attention is all you need. Okay, so another era changed from the 2017. First era is changed in 2012, and another era is changed in 2017 in the related to the neural networks, huh? Not another domains. Okay, so when we are talking about neural network is already there. Now, if you want to reach the transformer, you need to understand the neural networks. The root of that transformer is nothing but the neural network. So we need to understand the neural network first, and then we will connect this neural network with the recurrent neural networks. Recurrent neural network connect with the LSTM. LSTM connect with then the number of models, and finally we can reach with the transformer. And by using the transformer based models, we can see the different application in the market, that is the chat GPT, right? So if you want to reach the transformer, you need to understand the neural network. So I will take a neural networks. My role is to give the introduction about the generative AI. If you want to reach there, you need to understand the neural networks. What is a neural network? Neural network is a supervised machine learning algorithm. What is a neural network? Neural network has a different layers, like the input layer, hidden layer, and output layer. Okay, input is passing through these different layers and is producing the output. So you can understand the neural networks. But when we are talking about this neural network is inspired from human brain neuron system. Okay, this neural network is inspired from which? Human brain neuron system. Human brain neuron system proposed by some researcher, like as I already given the one example, like as the Dr. Hubel is given the theory how human can recognize the different objects. So you can also see this video on the net, right? So like as a pixel edges part of object in full object. You can see also there are different theories are there, but whatever the theory in the market, okay, this is a part of the biology, okay, but whatever the theory of this brain is present in the market, researcher are tried to design design the similar architecture, which is okay, we can say the Xerox copy of the human brain. Okay, still research is going on, okay, on the human brain, but whatever the theory is available, so we can say this is the neural network is inspired from the human brain neuron system. Okay, this human brain neuron system has a number of neurons. How many neurons? More than 80 billions. Okay, I think I don't know the exact that count, but there are number of neurons in human brain. If you want to understand the number of neurons, all are connected to each other. So before that, you need to understand the single neuron. Okay, number of neurons in human brains, and to understand the theory of number of neurons, how they will work, you need to understand the single perceptron. When we are talking, okay, when we are talking the neuron, you can see in the figure the one neuron connected to the another neuron, we can say this is the synapses. This one neuron has a different part as the cell body, and these different dendrites are there. Output is passed through the some axons, right? So whatever the output, one neuron connected to the another, this is the synapses. So whatever is doing as a central part is the cell body. What is the cell body? Okay, I will take a simple example. If okay, I'm taking the session and mosquito is okay on my shoulder, and I ignoring that mosquito because the mosquito is not harmful to me. But when he bite me, then that time I need to take action. Means what? He crossed the threshold. He crossed the threshold. I need to take the action, right? But that mosquito or whatever mosquito is there, it is on my left shoulder, and I'm taking the action through my right hand, right? When I'm taking the action, when he crossed the threshold, the role of cell body is same. Okay, when he send the message to the another neurons, if the threshold cross, and how we can decide how threshold cross by using the some activation function, by using the some mm, examples, like as you can see, mm, you can see this is a single neuron perceptron network. Input is coming, and in at whatever node is there, he is calculating something like as a first whatever the summation is there, whatever the summation is there, this summation, this summation is doing input x1 w1 x2 w2 and x3 w3. This summation is doing combining all the values input with the weights, okay, and pass this weight through the activation function, pass this weight through this activation function, and he is producing the output. So when we pass this net through, okay, we are calculating this net through the this active transfer function. I need to pass this net through the activation function, and activation function generate the output. Okay, you need to understand this theory. If you are saying yes, we already know this theory, then okay, there is no issue to understand the recurrent neural network. There is no understand, and there is no limit, okay, problem to understand the LSTM or transformer based models. Okay, this is the basic theory. What input is coming with the some weights, why we weights are required, strength is there, like as if HOD ask me, okay, tell me the topper from your class. Okay, how I can, okay, not a topper. Okay, we want to give the best outgoing student from our department. Can you tell me the some student name in the sequence? How I can give you this detail to my head of the department? Okay, if I know the percentage, if I know the extra activities achievements, if I know the different this data, then only I can say who or okay, he will be the topper or she will be the topper, right? So these are nothing but the strength of that student. Similarly, when I am saying the I have a knowledge of the deep learning, then this knowledge is nothing but the weights. If someone has a knowledge of the medical, he can say I am a doctor because he has the knowledge of that medical domain. Okay, when I am saying that I am a computer engineer, I have a knowledge of my computer domain. So knowledge is nothing but the weights. I want to give the training to my machine for what purpose? For example, type class, vehicle type classification, or for disease detection. So when I'm initially, he don't know the anything, right? We also don't know anything. When our teacher told me write the same digit same 100 times, so when I write the 10 times or 100 times one, then I understood the pattern of one. When my brain trained to recognize the digit, now after 30 years or 40 years also I can recognize the same digit, right? There's no need to write the same digit 100 times, right? This is the beauty of the that our brain. The similar techniques we are including in the neural networks. What we are taking the input, we are taking the input, calculate this input as a part of the summation net, pass this net to the activation function. This is a simple thing, and we can use this single layer perceptron. Okay, we can use this single layer perceptron for what? For a simple application like as a logic gates. We can solve and or this is a simple problems we can solve by using the single layer perceptron. But it has some problem because okay, this perceptron is not suitable for the non-linearly separable problems. Whatever the problems is there is there in diagram also you can see. I can divide this pattern by using the linear decision boundary. Where it fails, when patterns are the different patterns are there, class patterns are there, and by using line I can't divide, I can't divide this pattern in different category. In that case, perceptron is not useful. So in that case, we are using the back propagation. We are using back propagation means what? One neuron is not capable to solve non-linearly separable patterns. Simple. In one line, how we can remember. Okay, perceptron is eligible. Perceptron can handle some data which is linearly separate. Non-linearly separable patterns, we need to adopt the different number of neurons, not one neuron. On screen also you can see I am using the number of neurons are there. In hidden layers, some neurons are there. In output layers, some neurons are there. By using different neurons, I can handle the non-linearly separable patterns. Right? So if you understood the single perceptron, then the same theory is we are applying in the multi-layer neural networks. Okay, also we can say this is the multi-layer perceptron. In previous slide, we have discussed the single layer perceptron. In multi-layer perceptron, what is the now in next slide we can see the example. Okay, this is the figure of the multi-layer perceptron where you can see two neurons in the hidden layer. We can see the node and one node in the output layer. Okay, we are passing the two values. And what is the role of that neuron? The same. Whatever we have discussed. What we have discussed, we are taking the input, calculate the sum, pass this sum to the activation function, and produce the output. So whatever H1 is there, whatever the H1 is there, like as here also you can see, like as this is the H1, this is the H1, and this is a H2 is there. Okay, the role is same. Okay, what H1 is doing? H1 is calculating the sum and pass this sum through the activation function. What is the role of H2? Calculate the sum and pass this sum through the activation function. Similarly, this is the O1 node in the output layer. What is the role? Taking the input, calculate the sum, and pass this sum through the activation function. Role is similar. Role is similar. Whatever we have discussed. So for non-linearly separable patterns, we are using the input, pass this input to the hidden layers. Okay, and pass this output of the hidden layers to the output layers, and output layers is taking the action. Hidden layers is not taking the action, like as mosquito on my shoulder, right? And in between brain and shoulder, and this is the right hand. Number of connections are there, neural network, number of neurons are there. One neuron send the information to the next neuron. Who is taking the decision? Brain. Who is taking the decision? Brain. Okay, till we are just passing the values. We are just passing the value, like at the H1 and H2. What is the role of H1 and H2? H1 and H2 is taking the input, output, calculate the output and pass through the output layer. To take output, to take a decision in O1, we require a different activation function. Okay. Initially, we are using the one activation function, but nowadays to take the decision in output layer, if output is a binary classification, we can use the sigmoid. Okay, it output is a multi-classification, then we are using the softmax. We are using the softmax. In hidden layer, normally we are using the ReLU activation function. Okay, rectifier linear unit. So whatever the negative value, it is considered as the 0, and whatever the positive value, it is passing as it is. And at the end, we need to take a decision. So in output layer, binary classification is there, sigmoid is there. If multi-classification is there, we are using the softmax is there. So this is the basic theory. This is the basic theory. But now, if you understood the single layer perceptron, and if you understood the multi-layer perceptron, we need to understand the working of multi-layer perceptron, because most of the problems are non-linearly separable patterns. Okay, under which category? Non-linearly means what? We can't classify the patterns by using the line. We can't classify the patterns using the lines. There we use the non-linearly separable patterns. Like as if I'm taking, this is a circle, okay, cross is there, and around this circle different patterns are different. So this circle is not this is the non-linear decision boundary, right? So to classify this pattern in two class, I need to different approach, like as a backpropagation neural network is a solution for that, where non-linearly separable patterns are there. Now we need to understand the backpropagation neural network. Backpropagation neural, how it's work? Why? Because this is the topmost algorithm. Okay, this is the world's topmost algorithm to reduce the error. Okay, to minimize the error, to give the training based on the loss. We need to adjust the weights based on the loss. We need to adjust the weight in such a way that next time it is predict the correct output. And this is happening in multi-layer perceptron. At backend, which algorithm is there? Backpropagation neural network is there. Okay, and this backpropagation neural network is the popular algorithm to reduce the error. In that, there are two phases. One is a forward pass, and one is a reverse pass. What is a forward pass? In forward pass, what we are doing? We are just taking the input, pass through the network, and up to output layer. For example, my input is 1 and it is not predicting 1. Like as a simple example, digit recognition system. Okay, I am passing the 1 and it is not recognize the 1. Okay, then I need to change the weights. Like as for mobile, I am saying the remote, and for remote, I am saying the mobile. So I need to change the weights in a such way that next time I can say this is the mobile, and for correct label, whatever the remote is there, this is the remote. How I can change? Based on the error, I need to adjust the weight. Based on the error, I need to understand the weights in a such way that next time it predict correctly. So in forward pass, what we are doing, whatever the input we have passed through the all the nodes and generate the output. If loss is there, we need to roll back, and in a such way that we need to change the weights. We need to change the weights, right? So in change the weights, okay, in this case, I will take a one example. Okay, like as okay, like as if I am passing the 1, okay, and whatever my model is there, and it is okay, output is 0, 1, 2 up to 9. Okay, and it is not saying the 2, it is saying this is only 30%, it is the chances to it is a 2. What in this case, what I need to do based on this, what is the error? For 2 it should be 1, it should be 1, because I am using the softmax activation function, and if I addition of all the results, it should be 1. So if I am trying to find out the error, like as a 1 minus, okay, 0.30, so still 0.7 is error. Okay, still 0.7 is error. So 0.7, I need to reduce this 0.7 to 0, right? So based on this 7, I need to adjust the weights. For what weight? Whatever the nodes in this, whatever the input are there, whatever the inputs are there, is calculating the output. So input with, I can't change the input. What is the theory of supervised learning? We can't change the input. We can't change the output. What we need to change? We can change weights and the bias. We can change weights as well as the bias in a such a way that bias is means what? This is the additional factor with this node bias. Okay, if I don't have an input, how we can take a decision? So normally we are considering the bias with that. Okay, so when we are calculating, the bias, when we are calculating the net, how we can calculate the net? For example, three inputs are there, like as x1, x2, and x3. So we can say x1 w1 plus x2 w2 plus x3 w3. This is my net value. What I need to pass, I know the theory of supervised learning. What we know the x, okay, we know the y, and we pass this x through the function, through this function, and I'm training, give the training based on this supervised learning. And this function is nothing but the neural network. This function is nothing but the neural network. So in this case, x, I can't change the value of x, I can't change the value of y, I can change the value of w only. If when I pass this net through the activation function, usko f of, okay, net in nothing but the x, huh? When I pass this net through the activation function, I'm generating the y. If output is not as per my requirement, I can say I need to calculate the error. I need to calculate the error. Error. How I can calculate the error? Now, this is a label training. Huh? We have a label. So whatever the your model is predicting, this is the predicted output. This is the predicted output. We know the actual output. Actual output minus predicted output. Actual, it's simple theory. Huh? Just overview how we can calculate the error. Okay, we know the labels. So actual output minus the predicted output, whatever the error is there, like as a here 0.7 is there. So in this case, I need to adjust the weight in a such a way that, like as I hope you are familiar with the gradient descent algorithm, right? If error is there, like as if error is there, and I want to minimize the error near to the zero. So this is a zero. Okay, this is a local minima, and initially my error is here E1. So I need to reduce the error E1, E2, E3, E4 up to near to the zero, and this is the gradient descent algorithm. Okay, how we can reduce this error? So when I'm reducing this error, like as when we are reducing the error with respect to error, I am changing the weights. What is the new weights? What is the new weights? New weights equal to old weight minus learning parameter derivative of error with respect to weight. With respect to weight. So this is the equation. Another equation you should remember. Okay, and giving the more focus on back propagation neural network. Try to understand, because this is the very base for to understand the recurrent neural networks. I want to connect deep learning in CNN, RNN, and the transformer. So you need to understand the same theory is there. When I am telling about the some equations, you can easily understand. Yes, we have discussed, sir. We have discussed that. Okay, and when we are calculating the f of net means what? This is Wx. Okay, when we are talking about the Wx, extra bias terms is there, and based on that we are calculating the net. So how we can calculate the new weight? Okay, by using this equation. Okay, if you understood this, then you can understand that figure, right? Then in reverse pass, first we need to calculate. Now just come, okay, as a summary I will tell you. In reverse pass, what? In forward pass, in forward step, what you are uh, doing? Input to the hidden layers, hidden nodes, and output is there. If error is there, what we need to calculate? Total loss is there. With respect to that, we need to come back. Forward pass means what? Input, hidden, and output. This is a forward. But when we are going into the backward step, okay, in backward direction step, what we need to understand? We need to change the weights. How we can change the weights? By using this equation. Now we will come to our presentation, right? In forward pass, whatever the input is there, we need to pass through the all the nodes and calculate the output. If loss is there, we need to adjust the weight. What is the first step? First weight is calculate. First step is calculate the loss. So whatever this delta alpha is there, delta beta is there. Two neurons in output layer. So this is the alpha and beta. We need to calculate the loss. Like as in reverse pass, we are taking the gradient descent algorithm where we are using the derivative. Like as if here for understanding purpose, here we are using the activation function is a sigmoid activation function. Okay, activation function is sigmoid activation function. What is the sigmoid activation function? F of z equal to 1 by 1 plus e raised to minus z, right? And in forward pass, we are using this equation. Now, in reverse pass, we need to take a derivative. When I am taking the derivative of f of z, when I'm taking the derivative of f of z multiply by 1 minus z. So this is the derivative like that. So similar equation you can see here. So in reverse pass, in gradient descent, we are calculating the derivative, right? So first we calculate the loss of alpha, loss of beta. Okay, how we can calculate? Output of alpha, okay, 1 minus output of alpha, and this is the error. How I can calculate the error? Actual minus predicted. So this is the predicted and this is the actual minus predicted. So by using that, I can calculate, okay, I can calculate the loss. All right. So initially, how I can calculate the error? Error is I can calculate the error. Predict actual minus predicted, and based on that, what I can say, this is my error. The similar thing is there. Just for activation function, it is taking the derivative. So first step to calculate the loss, total loss, delta alpha with delta beta. Right. Now, with respect to that, I need to change. The value of the W alpha. Like as what is W alpha here? This is a WA alpha. Now, when I'm talking about the new weight of WA alpha, okay, new weight of A alpha, new equal to what I say, okay, old weight of A alpha minus learning parameter derivative of error with respect to derivative of old weight, right? So I have written this equation, right? So similar equation you can see here. When we simplified that equation, you can see this equation for new weight of A alpha is here. What is the new weight of A alpha equal to old weight of A alpha plus learning parameter error of next multiply by output of previous. Simple equation. Okay, when we okay, justify or simplify this equation. Which equation? This equation. Okay, you can see the similar equation here. Right. So what new weight equal to old weight plus learning parameter. Learning parameter means what? Okay, I will learning parameter what? In this case, you can see in this case, okay, error, we are reducing the error, the step counter. Okay, this step counter is nothing but the learning rate. So learning rate multiply by output, previous output, and next error. So with this simple equation, we can assign a new weight. Similarly, different weights are there, like as WA beta is there. Different weights are there in this output layer to the hidden layer in reverse pass. We are talking about the reverse pass. In forward pass, how we can say input layer, forward layer, output layer. In reverse pass, reverse output layer, hidden layer, and input layer. So first we need to give the new weights for output to the hidden layers. So by using that, by using this simple theory, okay, we can give the different new weights where from output to hidden layer. Now, what is the next challenge? Now we need to give the weights for now for this hidden layer to input layer. So this is, for example, this is the omega A is there. Omega is my input. Now for this omega A, output of A is going towards alpha and beta. Output of A is going towards alpha and beta. When we calculate the loss, I consider alpha and beta both. So I need to calculate first error of A, where I am considering alpha output as well as beta output. Okay, and multiply by what? 1 minus output A. So this is similar as the previous one when we are discussed how we calculate the derivative, and when we are calculating derivative of f of z, sigmoid activity function, it is saying that f of z, derivative of f of z equal to f of z multiply by 1 minus f of z. 1 minus f of z, right? So here again I am calculating the loss. This is the second step loss. This is a step of loss 1 of output layer, output loss, and this is the loss is for hidden layer. I calculate the loss and then I change the weights. I change the weights. Like as similar equation you can see here. What is the equation? I want to give the new weights for W omega A. So what is the equation we have discussed? New weight of omega A equal to old weight of omega A plus learning parameter next error output. No, sorry, next error loss means A error loss. A error loss and previous error output. Previous error, which one is there? Previous layer is the directly inputs, so you can say the input of omega is there. Okay, so by using the same theory, just what is the change in hidden layers, we need to consider the loss of next output layer, all the neurons. So here A output is going towards alpha and beta, so when we are calculating the loss of this A, I am considering the both is there. So this is very important. Many times students, faculty, researcher are unable to understand this theory. How backpropagation neural networks works in reverse pass. How we are assigning the new values in the reverse pass. New value in the reverse pass. So if you understood this backpropagation neural networks, then you can visualize now. Then we can visualize whatever we have discussed. What we have discussed, the number of steps are there. In left hand side, you can see the steps. Initialize with the random weight. When we start the training, we don't know the exact weights, right? So we start with the random weights. Feed whatever the weights is there, initial random weights is there. I start with the training. Okay, feed it through the to get output. So in forward pass, what we find output. I compare this output with the actual output. Okay, whatever the predicted output is there, I compare this predicted output with the actual output. If output is not as per my expectation, if loss is there, I need to retrain. So next step is what? Adjust the weight based on the error. This is the basic step. So in 4 lines, in 4 line, you can remember the theory of back propagation neural network in forward pass and in reverse pass. Just I will take a simple example to understand the back propagation neural networks. So in this example, this is the two class patterns are there. Okay, some orange dots is there, another class in different color. And initially with random weights, I draw the decision boundary. And this is a non-linear decision boundary. In one line, I can't classify the all patterns into class, right? So what I need, based on the error, I need to adjust the weight. I need to use the new weights, and then I retain next steps. See the decision boundary change. Still error is there. I need to change the weights. Third iteration, again my line is not proper. Again I need to change my decision. I need to change the weights. The next step also decision boundary is not correct. So finally, when in number of iteration, after some iteration, I can see this decision boundary classify the patterns properly into class. Okay, I have taken the one example. Okay, when I was in school, okay, my teacher told me write the same digit 10 times. Initially, I don't understand the pattern of the digit. So, okay, my teacher told me write the same digit 10 times. When I write the same digit 10 times, 10 times means what? 10 iteration. After 10 iteration, I understood the pattern of the one. Similarly, when I start with the random weights, machine can't recognize the properly, classify the properly. But after some iteration, definitely my machine is giving the correct answer. So for that we are saying this is the iteration. This is the iteration. I hope you understood the back propagation neural network, and this is the heart of the convolutional neural network. Try to understand. If you understood the single layer perceptron, if you understand the back propagation neural networks, now you can connect with this concept with the deep learning algorithms, right? Neural network is a part of the deep learning, right? Deep learning is about the learning multiple layers of the representation and abstraction to help to make sense of data such as image, sound, and text. Like the number of layers are there, I already discussed to you. Okay, we are recognize the number of patterns simultaneously based on the pixel edges part of the object and the full object. This is the 4 layer are there to recognize the multiple objects. Similar technology in deep learning. Similar technology deep learning. So you can see I need the different layers. First layer maybe concentrate on the image. Second layer is part of the edges. Third layer is edges, and fourth layer is the pixel. At the time of training, I need to think on this part, right? So as an example, you can see here the cycle or whatever the car is there. I want to classify the vehicle type classification. So I can use the different layers, right? So I hope you understood the deep learning. Whatever the machine learning, supervised machine learning and unsupervised machine learning. Similarly, in deep learning also, we can see the supervised deep learning and unsupervised deep learning. Convolutional neural network and recurrent neural network are the part of the supervised deep learning. Convolutional autoencoder, deep belief network, deep Boltzmann machine, these are the algorithms under the unsupervised learning. I am giving the more focus on the supervised deep learning, where recurrent neural network is the part of the transformer or the generative AI, what are the trends in the market, current trends in the market, multimodal AI, explainable AI, self supervised learning, or generative AI, right? So transformer based architectures, all these current trends are based on the some basic algorithm. Which two basic algorithm? One is the convolutional neural network, and second is the recurrent neural networks. If you understood the backpropagation neural networks, I just connect with this concept with the convolutional neural networks. So I hope you understand the backpropagation neural network. And last part of this convolutional layer is back multi-layer perceptron. So this is already covered. So whatever we have discussed, whatever we have discussed, this is a multi-layer perceptron. What we are doing, taking the input in forward pass. If error is there, we are doing the reverse pass. Now, in this case, we added the two extra layers in convolutional neural networks. We added two extra layers. Which two layers? One is the convolutional layer and one is a pooling layer. What is the role of convolutional layer? Okay, I already told you the difference between the deep learning and machine learning. What is the beauty of deep learning? Deep learning is extracting the features automatically. How we extract the features automatically? By using the convolutional layer. By using the convolutional layer. Okay, and to reduce the some complexity or to handling the overfitting, we are using the pooling layer, right? So the two layers extra is there for different purpose. Convolutional layer extract features, and for pooling layer downsampling the image, or it is useful for handling the overfitting, right? So how it extract the features? Okay, so this is the convolutional layer. You can see the equation for this convolutional layer. This is the equation for convolutional layer. Now you can,
Excuse me, sir. Sorry to interrupt.
yeah.
Your presentation is not being shared.
Okay, so I'm talking about the two extra layer in a CNN. Okay, first layer is convolutional layer, second layer is pooling layer, and actually three layers in the CNN, and third layer is a multi-layer perceptron. We already discussed the multi-layer perceptron where we are using the forward pass and reverse pass, right? Two extra layer is there for what purpose? Extracting the features and downsampling the image. What is the role of convolutional layer? Convolutional layer is extracting features. The basic theory of convolutional layer, I will tell you. Okay, when we combine the two colors, we can see the new colors. Everyone is familiar with theory, right? Main colors are there, RGB colors are there, red, green, blue. But when I combine red with blue, I can see the different color. Means what? I combining the two, I can see the new color. So whatever the image is there, my original image is there. Whatever the original image is there. So this is my input. Okay. I am combining a new color. I am saying that this is the kernel, or I can say this is a filter. Okay. I combine this filter value with the input color. I can see the different values are there. And this is my output. When we are talking about when I combine the red with the blue, I can see the new color. Similarly, when I combine the input with the kernel, I'm doing the dot product. Okay, this equation is for the dot product. And this dot product is like as, okay, f of x plus bias. Okay, so whatever we have seen, predicted output equal to wx plus bias. Huh? This is a simple equation to calculate the output in simple neural network. Similar kind of equation you can see. This is what? Okay, this is the weight. Here is it is giving the kernel, and x is input. Here it is giving the I value, and bias is there. So similar equation we can see. Similar equation they have used. Who? Jan LeCun is developed this architecture in 1989. In 1989 for his PhD. Okay, he designed a new architecture. Okay, and to extract the features automatically, and the name is the convolutional layer, right? The theory is what? Combining two, we can see the new. Similarly, we can use the same filter on the whole image. You can see the different values. So you can see the input size is 7 by 7, kernel size is 3 by 3, input size is 7 by 7, input size is 3 by 3. When I doing the dot product, we can see the output is a 5 by 3. Simple equation is there. You should remember. Okay. How we can calculate? Okay. Okay. Input minus kernel size plus 1. Input is 7 by 7. 7 minus 3, 4 plus 1 equal to 5. Equal to 5. So output is 5 by 5. Right? So by using convolutional layer, what we are doing, we are extracting the features. We are extracting the features. We are, okay, use the same filter. So we don't know which filter extracting which value, which filter is calculating the new, okay, extracting the new color. We don't know, right? We are doing the different combination of the colors. And in real time also, we know that by using these three colors, we can see the number of colors are there. Similarly, for first filter, which feature extracted, I don't know. So we are using the another feature kernel. We are using the third kernel. So like as a filter, 100 filter on 100, 100 filters on one image, I can extract the 100 features of same image. I will repeat. Okay, one image is there. I applied 100 filters on the one image. I can extract the 100 features. I can create 100 different images for the same input. And this is the beauty of the convolutional neural networks, where convolutional layer is extracting the features automatically, right? So, okay, as per the requirement, we can use the number of convolutional layer, 3 convolutional layer, 4 convolutional layer, 1 convolutional layer. Traditional approach is what? Convolutional layer, pooling layer, and multi-layer perceptron. For as per requirement, we can change, modified, or customize the CNN architecture like a convolutional pooling. Like I can customize this architecture as per my requirement, right? So in this figure also we can see I use the 3 convolutional layer, and input size is 28 by 20. When I applied the 3 convolutional layer, I can see the 16 by 16 is there. What is the role of pooling layer? I told you, downsampling the image. What is the role of convolutional layer? To handling the overfitting. Overfitting is the major problem, we know that, right? So for these two purpose, we are using the pooling layer. Pooling layer is also some limitations. Okay, actually, Jan LeCun did the PhD under the Geoffrey Hinton. Geoffrey Hinton is the godfather of the neural network, right? And you know that the Jan LeCun is also a well-known researcher who was the R&D head for the Facebook, and Geoffrey Hinton was the R&D head for the Google. Okay, Geoffrey Hinton already aware about what is the limitation of the CNN. So they remove this pooling layer and they launch a new architecture. Its name is a capsule network. Its name is the capsule networks. Okay, so without this pooling layer, he design another architecture for the different purposes are there for some requirement. Capsule network is giving the better result than the CNN. What is the role of pooling layer? I am telling about the role of pooling layer, handling the overfitting as well as downsampling the image. So we can say we are using the max pooling or average pooling, whatever the output of the convolutional layer. I use max pooling or I use average pooling. Max pooling means what? 2 by 2 grid is there. What is the maximum value? I can consider that maximum value, or average pooling, I can apply it on that and I'm taking the average of that 4 value and I can take the average pooling. So there are two methods are there. In some architecture use the max pooling, in some architecture they use the average pooling, right? But we can see 4 by 4 image directly 2 by 2. How? When I use the pooling. So downsampling the image. So the main purpose of the pooling is the downsampling. Input layer is 16 by 16. 64 images are there. Okay. And output of pooling layer is 8 by 8. 16 directly half. 8 by 8. So this is the convolutional layer and pooling layer. So these are the steps. Pass the input to the convolutional layer, then pooling layer, then multi-layer perceptron, and we can treat the output. So convolutional layer, like as a one input is there, this is the Marathi digit 7 is there. When we applied the 3 kernels, we can see the 3 different images of that 7. Similarly, when I applied the pooling layer, so input size is 24 by 24, output is 12 by 12. So this is output of pooling layer. Now, when I pass this input to the convolutional layer, like as on screen you can see, I applied 30 kernels. I applied 30 kernels. So I received 30 features of the same input. Like as you can see on the screen, 7 is there. And when I applied the 30 kernels, I can see the 30 outputs are there. And all these 30 images I can consider as a feature to recognize the 7 digit. When I put all 31 by one back and I can see this one, so this is the 7. But when I consider separate part, yes, I can consider this is the part of that input image. This is the part of that input image, and I can consider this is the feature. Like I want to recognize the face, so I need a features. Like as a human, I can extract the features. Eyes are there, nose is there, hair is there. So these are the features to recognize the face. Similarly, to recognize the 7, I require a different features. So in this case, I can consider these 30 features. I can consider these 30 different features to recognize the 7. To recognize the 7. For case study, input is 2. I pass through the machine learning algorithm. Okay, so I can't pass as it is. So this is a 16 by 16 image. So vector is 250. I pass through the machine learning and predict in output, not in one digit, 0 to 9, 10 digits is there. So input values are 256, output value is 10 in 10 class. I need to pass this value to the functions, and this function is nothing but the deep learning. This is nothing but the deep learning. So for example, okay, this is the image, one image. I want to recognize the disease of that image. So I can use CNN and to predict the disease of that. But okay, so as a summary, this is again one case study is there. Another case study is there. I have input image is the 4 digit recognition system Marathi. So I pass this input through the convolutional layer, pooling layer, and multi-layer perceptron, and I can recognize the 4. This is the output for when I pass this input through the different convolutional layer. I can see the features. So I applied 64 filters. So for one input, I can extract the 64 features to recognize this particular 7. So this is the beauty of convolutional layer. I use the pooling layer, downsampling the image. Whatever the output 16 by 16, I downsampling 8 by 8. So after that, I pass through this input to the multi-layer perceptron, where multi-layer perceptron, hidden layer is there, output layer is there. Hidden layer, you can see the output. I am not classify the digit in hidden layer. So whatever the input is there, calculate the value. How we calculate the value? We already seen. Calculate the net, pass this net to the activation function. In output layer, what we are doing? We are doing considering this in output of the hidden layers and using the softmax activation function, we can predict. So already these the outputs are based on the already trained model. So it is giving the 7. It is giving the 7, right? So similarly, you can apply on the different data set, like as the MNIST data set is there, or different data sets are available on the Kaggle. You can use, okay. Also, you can implement the CNN by using the different framework. Okay, I implemented by using the TensorFlow. Okay, you know that in Python we can easily implement the deep learning algorithm. So I use the TensorFlow, but whatever you are aware about the language, by using that language, like as a C, Java, MATLAB, you can implement the CNN. This is the first part. But for this CNN, some challenges are there. We are talking about the CNN. Okay, almost I covered the half part of my session. I will take a small break after 5 minutes. Okay, or 1-2 minutes. I will take a small break. But CNN we covered. Okay, but CNN is very good for the image. Like as whatever the input data you think like as image, then definitely you can use CNN there. But on text, on sequential data, in sequential data, CNN is not good. In that case, we need to understand recurrent neural networks. Some challenges are there. Okay, some challenges are there. What challenges with the CNN? CNN is not good for the sequential data, like as a text data, like as a, for example, stock market condition. Time to time, the shares values are different, and based on the last 50 years of that shares, I want to predict the tomorrow's price of that stock, particular stock. In that case, in this time series data, CNN is not good, or I want to predict the tomorrow's temperature. In this case, I can't use CNN is not good, or like as in email, when I'm typing the some sentence, the machine itself is predicting the next word, right? Or in chat gpt, okay, best example is chat gpt. When I'm asking something and he's giving the response, or when I'm giving the one paper to chat gpt and telling give me the summary of that paper, in that case CNN is not good. In that case, we must use RNN. Okay, CNN has advantage. We can use the CNN, but whatever the different trends in the market of the deep learning, okay, there are different trends: self-supervised learning, generative AI, transformer based, zero shot, learning, generative as well networks are there, explainable AI, number of uh, trends are there, reinforcement learning is there. We need to focus on the generative AI and transformer based architecture. So in this first session, I tried to cover the basics of the neural networks. What is the basic? What is the perceptron? What is the multi-layer perceptron? What is the theory of multi-layer perceptron? Forward pass, reverse pass. How we can use this multi-layer perceptron in CNN? What is the architecture of CNN, and how CNN is trained, and how CNN trains, and what are the different components? What is the role of convolutional layer? What is the role of pooling layer? And what is the role of multi-layer perceptron? But at the end of this session, we have discussed what is the limitation of CNN. What is the limitation of CNN? If you want to recover this limitation of CNN, we need to understand the recurrent neural network. We need to understand recurrent neural network. What is the, this is the new? No, neural network is already there, but how we can handle, how we can handle some application, different application, like as a speech recognition, huh? Like as a music generation, like as a sentiment analysis, like as a machine translation. Okay, so like as a DNA sequence analysis, in that case, CNN is not good. So we change the basic CNN architecture in a such way that he can handle the sequential data also. This part I will cover after a small break. Okay, I need a small break. So after 5 to 10 minutes, I will again start with my second session, where I will cover recurrent neural network, LSTM, and transformer. Okay, so we'll take a small break. Is it okay, Beb? Hello? Shall we take a small break?
Yes, so sure, sir.
Yeah, okay, ma'am. We'll join after 5 to 10 minutes. Okay.
Okay, sir. Dear participant, meanwhile, we'll share you the quiz link on the chat box. Please fill that.
Anyone having any doubts, you can drop your doubts in the chat box. At the end of the session, sir will answer them.
All participants are requested to be present in the meeting. Meanwhile, you can fill up the quiz. Sir is back again here, I see.
Okay, shall we start, ma'am?
Yes, sir.
Okay, so in first session, we discuss about the different concepts of perceptron, multi-layer perceptron, and CNN. And at the end, we are discuss about the limitation of the CNN. Like as some applications where CNN is not good, like as speech recognition. I want to recognize the speech and I want to, for example, convert the speech audio into text, or another example is I want to generate the music, like as I want to listen the romantic songs. So based on that one text, I want to generate the audio. Okay, here you try to understand the input is the text. Input is text. So in first example, this is audio, and we are converting audio into text. In second application, input is text, and we are generating the audio. Third application is sentiment analysis, like as paragraph is there, like as a new movie came into the market, and based on the user comments, I want to give the remark about that movie, whether this movie is uh, positive, good or not good, or I want to give the rating. That is a sentiment classification. So this is the multiple text is there, and I want to give the output like as a positive or negative. Another example is DNA sequence analysis. So we know that corona situation, we need to analyze the DNA and chromosome based on the different changes in that chromosomes. We are giving this some recommendation to the pharma company to launch a new medical. So in that also we need to understand the different sequences of the DNA. Next example of RNN where CNN is not good, like as language translation, like as I want to convert the Hindi into English, or I want to convert the Marathi into the English. So in language translation, also CNN is not good. Like as another example is video activity analysis. I want to give the summary of that video, or like as image captioning. Like these are the examples where CNN is not good. So in this case, when we compare the CNN with RNN, okay, so CNN is good for spatial data, like as a images, right? So while RNN, the we have discussed the two algorithm in supervised deep learning. One is the convolutional neural networks, and second is recurrent neural networks. CNN is good for images. Recurrent neural network are good for sequential data, like text or speech, right? So this is the basic difference between the CNN and RNN. CNN and RNN. So when we have discussed the CNN, okay, we are discuss about the different layered architecture, right? And for what? And our major focus on the image. In RNN, when we are talking about the RNN, we are handling the text, time series data. In short, in time series data or text, okay, where RNN is good. But when, like as I want to predict the next word, like as a please find the attachment, or when I'm searching something, or when I'm asking something to ChatGPT, and based on my comment, ChatGPT is giving the response to me. Okay, so my question is one question to question answering. So okay, and my ChatGPT is giving me the output. 1 minute. Okay, sorry, sorry for interruption. So I'm talking about the RNN. So here CNN is not good. Okay, in the sequential data or in text, we are not using the CNN. So we are giving the preference for the recurrent neural network. Okay, so first important thing you should to understand is, okay, what is the basic difference between this supervised deep learning, two supervised deep learning, CNN and RNN. CNN is good for image, RNN is good for the sequential data and text. Now, when we combine both, yeah, definitely we can create a new models. We can handle the both image as well as the text. Now, to understand the recurrent neural networks, okay, name itself saying the neural network. So already we have seen the neural network part. We have seen the perceptron. We have seen the multi-layer perceptron, and we have seen the CNN. Right. Now, what is the recurrent neural networks? Recurrent, bar. Okay, I want to run same function again and again. Okay, so like as I have input, I want to generate output. Okay, but recurrent networks, I want to run the same app function many times, right? So sequence means what? Sequence means what? Like as if I'm taking a simple example, if I'm saying, okay, please find the, I want to predict the next word, right? So in first stamp, I am considering this x1 as a please. In second time, I am considering x2 is a find. In third time, I am considering the find. And I want to create one model. Okay, I want to create a model like as I want to pass this x1 through my model. Okay, through my function. Okay, through my function, it is okay, generating the output like as y1 for x1, right? I pass this x1. Please find the attainment. I want to send 3 words. So this timestamp is for please. Then I send the second word as a find with my function. With my function, again I generating the output with this x2. This function is taking the input from previous timestamp as well as the current timestamp, and based on that he is calculating the h2, and by using this h2 he is calculating the y2 for the x2. Again, consider as the h2 as an input, and the third word, whatever my word is there, the, and I pass through the function. Again, I am generating, okay, calculating the some value of h3, and by using the h3, I am generating the y3, right? Now, based on that, here you can see the, okay, every time we are considering the previous. So before h1, no one is there, so I am considering the h0 is there. So here you can see I am running the same function f1, f2, f3 many times. How many words are there? So many times I am repeating to execute the same function. So we are saying this is a recurrent neural network. Okay, this is the recurrent neural network. So when we are talking about the text, what in timestamp, what we can say, this is the time in timestamp 1, in timestamp 1 x timestamp 1, I'm passing the x1. In timestamp 2, I am passing the x2, and in timestamp 3 I'm passing the third word, right? So x1, x2, x3, I am passing in different timestamp, right? So when I calculate the diagram, right? Like as how I can calculate the value, like as in supervised deep learning, okay? In CNN, how we calculate? I pass the x through the function and generating the y. So this is the equation. This is the simple equation. Now here also y1 is there, y2 is there, y3 is there, right? H1 is timestamp 1, H2 is timestamp 2, H3 is timestamp 3. I'm talking about that, right? What is the equation? What is the equation? For similar equation, how I can write? So for that, I can say for this particular timestamp, I pass the value of what? I pass the value of previous timestamp output multiply by current timestamp input. Okay, so this is the simple equation. F of x means what? Here f of x means what? F of x is nothing but current as well as previous. Current as well as previous, right? And based on that, I can calculate the output. Output means what? For this y1, this is a y1 at timestamp 1. So how we can write the equation? Y at particular timestamp, how? Weight of whatever this output is there, uska bhi weight rahega, right? So weight of this, for this x1 also weight is there. Okay, for every synapses, for every edges, weight is there. For every node, weight is there. So for weight of what? Weight of h, weight of hy, weight of hy multiply by what? H of t at particular timestamp. So this is okay, this is the basics to understand the recurrent neural networks. Okay, how he is trying to consider the output of previous word. What we need to understand? We need to predict the next word. What? I know the third word. I know the third word, and based on this third word, I want to predict the fourth word. So when I'm calculating the value, okay. So in this case, when I'm calculating the value of x2, I need a value output of x1. Okay, when I calculating the output of x3, I need a output of x2. In x2, already I consider the value of previous word. So we are trying to maintain the relation between the different words, and based on these different words, okay, we train the model in a such way that he can predict the fourth word. So for that training, I required a data set. For that training, I required a training. And in which activation function we are using? In hidden layer, here we are using the ReLU. In CNN, normally we are using the ReLU. Here we can use the ReLU as well as TANH. Okay. So instead of F, I can write the TANH. Remaining is for T minus 1. Weight is there, T minus 1. So weight of HH plus weight of XH with input. So this H of T, sorry. Okay. Okay. H is H T minus 1. Okay. Plus weight of XH X of T. Okay. So I am using this TANH function, not plus here. Okay. I am considering both T minus 1 previous state as well as current state. Basic equation is this one. At particular time step, how we calculate the net, and by using this net, every time we are considering the weight, I pass this weight to the activation function and I generate the output. Now come to this diagram. So this is related to the timestamp. What we are doing in time series data in text. Okay, at particular time we pass the particular input. Like as x1 I pass first word. Okay, x1 I pass first word. Whatever the output of first word, I consider as an input for the next word as well as the next word. Okay, when I calculate the third, I consider the output of previous as well as the current. Previous out with current. Previous means t minus 1 and current means with t. By using that, I'm calculating the value of third. Right? So this is the basic theory of neural networks. This is a basic theory of neural networks. Like as in this diagram also, okay, we put some parameters like as in convolutional neural networks. Okay, when we are writing the equation like as y equal to wx plus ys, when we are writing this equation, in this equation there are two parameters. One is one is a w and another one is a bias. Only these two parameters in our hand to change the values. So normally a bias value is fixed, so we are changing the weights. So for these weights, okay, we calculate the loss. Based on the loss, we are changing the weights. And to write new weight equal to old weight minus learning parameter, derivative of error with respect to error. So by using that equation, we are assigning the new weight, right? Similarly, we are using the different parameters. Where parameters, this is x1 with weight of ax. Previous a0 is there, so there is a is there, right? For this, you can understand okay better. Like as this is a current, x2 weight of x2. Okay, previous output is a1, so WAA. Okay, output of previous, and calculate with this. What we are doing, calculating the summation, pass this summation to the activation function, and whatever the output is there, h2. Okay, pass with this equation y equal to, okay, so y equal to w hy ht. Okay, with this equation we are calculating the output. Okay, so when here we need to understand, this is the recurrent neural networks, but every time we are doing the same thing, so we are saying the recurrent neural networks, we need to understand how, what are the different parameters. Okay, in different time series, in first we are sending the first, in second timestamp we are second the second, in third timestamp we are sending the third. Based on that, in each time we are combining previous one as well as the current one. And this is the beauty of convolution, this is the beauty of recurrent neural networks. But here also we are using the forward propagation. Here also we are using the this is a combined. Okay, whatever this diagram is there, for all these x1 x2 x3 x4, we can replace with this generalized diagram. This is my input, this is my output, and we are repeating the same functions with the weight, right? So x has the weight, y has the weight. Okay, and every time we are executing the same function, this is a recurrent. So sometimes we can see the such kind of figure also, right? This is the recurrent neural network. In that forward propagation, okay, how, okay, already I have written the equation with the damage, right? In forward propagation, what we are doing, whatever the initial output of previous one, so we are starting with the x1, so we are passing, this is current x1 with weight, previous output with the weight. Okay, addition with that, bias is there. So we can say y equal to wx plus bias. This is a similar equation. This is the similar equation. Whatever this we are calculating the net, and usko hum whatever net is there, pass this net through the activation function. Okay, so for net we are saying the z equal to 1 plus e raised to minus z. So this is the sigmoid activation function. So similarly we can see here we are calculating the value, and g is nothing but the function. G is nothing but the function is there. And output, how we calculate the output? So already we have written the output. Okay, for a1, for example, I want to calculate the value of a1. So weight of output of a1 with the weight plus bias is there. So by using that we can calculate the output. Every time we are doing the same thing again and again and again. But when we are discussing the convolutional neural network, we started with the single layer perceptron. Similarly, when we are discussing the recurrent neural network, you must understand the working of first word. Same working is for every word. Okay, but this recurrent neural network has also some problem, vanishing gradient problem. In forward pass it is okay, pass as it is, but in backward pass, if sentence is there like as a sentiment classification, so one paragraph is there, right? And based on that many words, I want to predict the positive or negative. So this is the one. So this application is many to one. So I pass the number of words is there and I want to predict the positive or negative. Initially, if it is not giving the correct output, I need to backtrack. In backtrack, what we needed? Again, whatever we have discussed in the backpropagation neural network, we need to calculate the loss. We need to calculate the loss of each output. So each timestamp, combine this loss, and with respect to this loss, we need to change all the weights. We need to change this all the weights. In what? In reverse pass. In this reverse pass. So in reverse pass, with respect to loss, I am changing the weights. How? We are discussing backpropagation neural network. When we have discussed the multi-layer perceptron, in that already we have discussed how he changed the weights. In backpropagation neural network. So I have taken some more time, okay, on to understand, to give the knowledge about the backpropagation neural network. Same theory is there, forward and backward. Okay, in forward we are passing the input to the network, calculate the output. If loss is there, you adjust the weight as per the loss. So here you can see the equation also. How we calculate the loss. Okay, now we update the weight with respect to error, okay, by using different algorithms like as a gradient descent algorithm. Different optimization techniques are there, like as a gradient descent algorithm is there. Okay, ada delta is there, momentum is there, Adam is there. Okay, momentum is there. Okay, RMS probe is there. Okay, ada delta is there. Different optimization techniques are there, but here we need to understand, yes, with respect to error we are changing the weight. Now types of RNN is first is a one-to-one. Means what? One input, one output. Giving the output is a dog, I want to predict the dog. One-to-one. Okay, what is the many-to-many? I am giving the many input and I am predicting the many output. So many to many, like as you can see the diagram also. You can see the diagram like as whatever the RNN diagram, it is suitable for the many to many. X1, Y1, X2, Y2, X3, Y3. Many input, many output. This is the many to many. Many to one, like as a sentiment analysis. I have discussed sentiment analysis. I need to different text X1 and X2. This is a simple diagram. So based on the different input, I want to predict one only. Many input, one output. Many to one, recurrent neural networks. And many to, last one is one to many. Like as I want to listen the romantic songs. So one input is there, and based on that, I want to generate a sequence of audio, right? Right. So this is the example of one to many. Theory is what? Theory is what? In recurrent neural networks, okay, in timestamp we are passing the words. In timestamp we are passing the word. Like as the one example is there, the color of parrot is. So in X1, I'm considering the. Okay, at X2, I'm considering the second color. At X3, I'm considering the third of. At X4, I'm considering the parrot. At X5, I'm considering the eighth. And based on that, I'm predicting the fifth word. If I train my model with the different data set, different texts, okay, based on that training, he can definitely generate the next word. Like as if I'm asking, how are you? How are you in ChatGPT? Okay, it is generating the response fine, like as fine, or he can use the some sophisticated answer like as yes, I'm fine and weather is good and like that. Okay, what about you? Like that, he can add the some extra things also. But okay, he can predict the next word. So this is a simple task of the recurrent neural network. But this recurrent neural network also some limitation. Which limitation? In backpropagation neural network, okay, X1 with X2 with X3 with X4, for example. In reverse, he is changing the weight. In reverse pass, he is changing the weights. Like as I want to change the weight is point, okay, 0, 1. Okay, in x to 2, I want to change the 0 again 0, 1. When I multiply 0.01 multiply by 0.01, it is okay 0.00 okay 0, 1, right? So it is more less changes, and when I change small change, it is a very small change at the time of x1, so in this case, for example, this x1 new, this w1 new is almost equal to w1 old. If I doing the small change, this is a very small change in backpropagation neural networks. This is a vanishing gradient problem. This is the main problem with the recurrent neural network. This is the main problem with the recurrent neural network. In large, he has no memory to remember all the words. Okay, sentence is large, like as this is one paragraph, big paragraph, and based on that big paragraph, I want to predict some words after 100 lines, and this is one predicting the next word. It is not easy task. So RNN is not capable. RNN is not capable because RNN has two problems: vanishing gradient and exploding. Exploding means what? Reverse thing. When I multiply 10 by 10, 100, again multiply by the 10. So sometimes small change, very small change, large change, very large change. Okay, so this is the problem with the RNN, and we solve this problem with the LSTM. Okay, so with short term memory, right? So this RNN also some limitation. Okay, what we have discussed? We have discussed two things. CNN has some limitation. It is good for image. For sequential data, we are using sequential data or time series data, RNN is okay. But RNN is also some limitation. Okay, he can't remember the large sentence. He has no memory. So add with the memory and researcher launch LSTM. Researcher launch LSTM. LSTM launch, I think 1996. RNN launch in 1980, around 80. Just I have 1986. So in RNN launch in 1986, okay, RNN has some limitation. RNN has some limitation. So to remove this limitation with the some memory, LSTM launch in 1997. Okay, LSTM launch in 1997. To what? What is the problem? Problem with the memory, large memory. RNN can't remember the if sentence is long. He can't remember all. Means what? Okay, like as x1, x2, x3 up to x99. And I want to predict the 100 words. X100. What will be the word for 100? So he can't remember all. He has some limitation. So with that, some researcher added some memory cell concept. Okay, memory cell concept, this one. And okay, some additional. Previous is same for the RNN, but he added some extra cell state. What is the role of extra cell state? It is a remember. It is trying to remember the important word from the previous text. Like as I like mango. I like mango. Which is the important word in these three words? Okay. Or after some sentence, my name is Deepak. And Suraj is also like the fruit, which is like to the mom, Deepak. So when I'm giving some reference of this previous word, okay, so in cell state, what is the role of cell state? For this particular word, this word is, what is the importance of this particular word with respect to all remaining words in the sentence? Okay, and based on that, he is storing the output in the cell state. He is storing the output in the cell state. Okay, this is a small change in the LSTM, long short-term memory. Okay, like as this is sentence. This is a sentence. Huh? Today, due to my current job situation and I dash to take a loan. Okay, so I need to predict this particular word, need. Okay, at particular timestamp, xt is there. Previous timestamp t minus 1 is there, and after this t plus 1 is there. But additionally, cell, this is the cell states. I can say this is memory state, who is trying to remember the words. But in LSTM also, some limitation is there. What? We are sending word x1, x2, x3, x4 if text is large. Text is like as a textbook. Like as a textbook. How this textbook is read by this LSTM? It has also some limitation. I want to give the training to my machine with this textbook, like as C language, How many books are available in the market? For example, 100 books. I have C language book. How many books? 100 books. I want to train my model with these 100 books. I want to train my model with these 100 books. And based on that training, I can ask the query related to the C language. when my model is giving the correct answer, when I give the proper training to my model, then only my model is giving the correct response. Like as a, what is the use of pointer? Why? Okay, what is the use of pointer? What are the different types of function? Like as a different example, I can ask, and based on different knowledge, he can extract give the response. Plus, when I'm saying this model is expert, this is my model is expert model. Like as some words are not present in that model in training, at the time of training, then also he's extracting the new knowledge. New knowledge from existing knowledge. Okay, this thing is not happening in LSTM. This thing is not happening in LSTM. So to send 100 books, to send large, now in this case, what is large language model? Okay, large language model. If we remove language, what is the word? Large model. Large model means what? I can train my model with large data. For what? Large language model. At that time, this word came into the picture. What? I have a large data. For C language, many books are there. For my particular project, many reviews are there. Sentiment analysis. For translation, machine translation, grammar based books, many books are available. Right? How I can train? So, new concept came into the market and its name is a large language model. And to give the large language model, okay, so everyone is trying to train. Everyone is trying to train, like as Google. Okay, initially OpenAI came into the market, right? Like as a Chat GPT. Okay, Chat GPT means what? Huh? Generative pre-trained transformers. Generative pre-trained transformers. So everyone is trying to train their models on the large data, large books, means large text. And based on that, new application in the market, like as machine language, sorry, machine translator, like as a machine translator, like as text to video, like as a recent whatever we are using, Chat GPT, another application, like as a text summarization. I want to give the PDF and I want to ask what is the summary of this paper, summarization, right? Or whatever the question answering is there. So this is Chat GPT is also question answering, but these are new challenges in the market, question answering. Okay, speech recognition. Okay, and some particular domain wise, like as a medical domain wise, particular medical or financial, I want to ask something, right? So different application, different requirements are there where I need to use the LLM model, where I need to LLM model. And LLM base models, whatever the LLM base models, in 2017, okay, one paper came into the market. Its name is the attention is you all need. Attention you all need. Attention you all need. One paper is there. This paper published in 2017. Okay, this is the title. Attention is all you need. Beauty of that paper is this architecture. Directly I come to the architecture. They come with this architecture. What architecture? We are saying if you want to launch, this is okay. This is the wait. This is the transformer based architecture. Where this model consists of two. One is the encoder and one is a decoder. One is a one is a encoder and another one is a decoder. Encoder is trying to understand the input. What is the role of encoder? Okay, what is the steps? Okay, what is the steps of this transformer? What is the transformer? Okay, he is taking the text, large text, like as books. For C language, 100 books are there. For each word, what he is doing? Okay, he is using the encoder. Okay, encoder, then attention model, and then decoder. Means what? Whatever sentences are there, what he is doing, he is first tokenize. Okay, he is first tokenization. Whatever the tokenization is there, like tokenization means what? If I am saying, how are you? So he is giving the numbering. Tokenize first sentence, giving the some numbers. For that, what we are telling, this is embedding. Okay, means for this text, he is converting into the vector. And this vector is not vector. Many vectors are there, like as I don't know the exact amount, but almost 2200 numbers are there in one vectors, and he is all vectors stored in the one concept is there, direct embedded matrix. उसको बोलते हैं embedded matrix. Its size is contain almost 22 crores, like as 21 crores, whatever I saw the values on the net. 21 crores values are vectors are there, values are there. So this is such a big vector matrix is there. Okay, and after that transformer based models, what they are used the attention. Attention means what? In this paper also, what they are trying to focus, they are focusing on the attention. Attention means what? In this particular text, which word is important, which word has importance. Like as I like mango, so in this word mango has an importance. Okay, I am okay, I like to play a cricket. So which word is important? Cricket. So when human is giving the attention on some particular words, like as if someone is telling us the story and we are remembering the some keywords. Okay, remembering the some keywords, and based on that keywords means nothing but my attention, and based on that attention I can give the some suggestion, predict something. So this is whole theory based on the attention. Attention means what? Giving the importance of the words, which word is important in my text. Okay, then he is using the forward. We know that the forward layer. What is the forward layer? We know the forward layer, and based on this forward layer at backend, he is also use the reverse case, unembedded matrix, whatever the attention value, keywords values are there. He is using the another matrix is there, another multiplication, 61 crore multiplied by 61 crore. So large. Again, he has some matrix values there, like as a black box, we can't see all the values, but based on that, he is what predict. Important thing is predict next token. Next, predict the next token. Okay. Predict the next token. Like a simple example, if I'm asking you, okay, 11, 22, 33, what is the next value? You can say, sir, this is the 44. We are not calculating, we are predicting. In such a way that in transformer, when we are giving the 2 plus 2, he is not doing the calculation, he is predicting. He is predicting through what? Through the encoder and through the decoder. What is the beauty of encoder and decoder? What is the beauty of encoder? I just want to share the transformer beauty. What? Transformer what? This is also deep learning model. But for what? To understand text, to understand languages, to understand the sequence data. But what? Whatever the earlier model, which model? RNN, which has some problem, vanishing and gradient problem. Also, LSTM, long short-term memory, okay, has a problem with to understand the large amount of data, okay, which is slow and had difficulty remembering the long sentence. What is the role of transformer? Transformer solve this problem. What? With what? With all words at the same time. Here it is not passing at the timestamp x1, x2, x3, x4. At the time he is passing. As I said, if someone is telling us the story, what we remember? We remember the keywords, and these keywords is nothing but the our attention towards that story, to listening the story, right? To calculate these keywords, right? We use the attention model. We use the attention model. In transformer, two parts are there. Encoder understand the input, decoder generate the output. To understand the input, what is the input? Embedding, tokenization, attention. This is the part of encoding. Self attention model. In figure also, okay. In figure also, you can see what is this. This is a multi-head attention model is there. Here also you can see feed forward is there. So feed forward, we know that, sir. Forward pass error is there, passing the input as it is through the network. Forward pass is self attention means what? Tokenize the steps. Okay, tokenize the steps, give the numbers, attention words, use the some embedding matrix is there. Okay, and based on the embedding matrix is trying to predict the next token, right? So this is an idea about the transformer. This is the idea about the transformer. What? So it is the important thing is there. We are not passing words time with timestamp, all words together, and predict the values. Like as transformer is a deep learning model based on the self attention that process the input data in parallelly to capture a long range dependency, like as ChatGPT, or like as language translation. It is not easy task, right? So when this technology came into the market, era is change. So I told first era change in 2012, second era change in 17. Okay, after that many models came into the market, like as Electra is there, BERT is there, T5 is there. Almost 50 to 60 models are large language models came into the market. All are based on the transformer base. All are based on the transformer base. Okay. So this is the encoder decoder, whatever I am explaining. Okay, encoding decoding. So in encoding decoding, understand the data by the encoded and generate the output by the decoded. Important thing is self attention model. Self attention model. So many pre-train, okay, like as we know that AlexNet, we know that VGG16, we know that Google Net. What is this? These are, okay, basic algorithm is what? Basic algorithm is, sir, CNN. Basic algorithm is CNN. But this all, okay, all pre-trained on large data set. Which data set? ImageNet. These all models are trained on what? Large data set. Similarly, many pre-trained data sets are available, pre-trained models are available. You can use that tomorrow in tomorrow's session. Fine-tuning, fine-tuning concept will cover by the another experts. Okay, there you can understand pre-train means what? Pre-train means what, right? So in transformer, encoder and decoder is there. Main components are self-attention. So give the attention with the word. What is the importance of word with the another words? Encoder, understand the input data, convert words into the numerical representation. As I said, embedding, like as embedding. Decoder, generate the output. Like, what generate? Generation the question for your questions, generating the summary of the input, like that. This is the main components of the generator. Transformers. Okay, positional encoding, transformer, positional encoding. So transformer read all words together, and they need to help to understand the word orders. So this is the positional encoding. Examples where it is important, like as ChatGPT. Normally we are using the ChatGPT. OpenAI launched the ChatGPT. It's used at backend transformer concept, and he trains on data, large amount of data. I mean, if you are asking me where is the large amount of data, like as Google has a large amount of data, like at backend. So they train their models. Okay, like as a BERT is also there. Gemini is also there. Llama, developed by the Meta. T5, given by the Google. So many transformer based models are there. You can use the pre-train, okay, train weights. Train weights, like as a transfer learning. What we can do? We can use this train weights model. Which model? Alexa, pre-trained models like the AlexNet, VGG16, Google Net. I can use the trained models and I can run. Similarly, pre-trained models are also available. Okay, so different applications are there where we can use the transformer. Like as already we have discussed, the ChatGPT, language translation, query summarization, question answering, speech recognition. Here we can use the transformer base, right? So many pre-trained transformer model are also there, but what do you need to understand? What do you need to understand? Understand is CNN image, RNN text, LSTM large text, and transformer. Okay, not in sequence, all in one. All at the time. Okay, in one time, all in one time. Right? Different models are available, like the ChatGPT, generalized traditional model, ChatGPT, Gemini, Cloud, Llama, right? These are the different models are available. Like as different domain specific transformer model is also there, like as a finance, like as a finbot is there for the finance. For medical also different domain specific transformer is available, like as a bio GPT. You can use G, generative, P, pre-trained, T, transformer. So you can say chat GPT 3, chat GPT 3.5, 4, these are the all the models based on the transformer, where they have given the training in one time. They have given the training in one time, right? So as a summary, we have seen the different concepts. We have seen the different concept, starting with the neural networks. Starting with the neural network. Okay. Now, transformer based different AI model is available. Now, what is the generative AI? We are not discussing the generative AI. CNN is for image, RNA is for text, right? As well as sequential data, right? We extended the models, different models also used for the different types of data, multimedia data, right? Reverse thing, text to image, image to text, text to video, video to text. Initially, we are using image captioning. Now we are saying we are typing the some text and he is generating the image. Yes, definitely. Generative AI is a type of artificial intelligence which create new original contents like as a text, image, music, codes, videos by what? By learning the patterns from the vast data set rather than just analyzing the existing information. This is a generative AI. Just I want to connect three different technologies, trends in the market. We are starting with the AI. What is the AI? Machine can think like as a human. This is the objective, right? Artificial intelligence, but not suitable for some like as if I am asking uh, uh, to chat GPT, okay, directly I am asking what is my name? What is my name? If in previous history, if he has no data, okay, he can't give the answer. So chat GPT is also some limitation. Okay. Chat GPT is also has some limitation, right? We are not saying chat GPT is giving the answer for each and every inputs. Okay. Each and every inputs. So when we are talking about the AI, what is the AI? Making system with intelligence, right? So making system with intelligence, in that at backend we are using the machine learning. So when we are talking the AI, machine should be the intelligence by using the ML, right? What is the generative AI? Generative AI generate what? Generate text, generate image, generate video, right? So when we are talking, what is generative AI? In generative AI, when we are talking about the generative AI, initially we have discussed the concept what? Large language models. Large language model means what? Always remember one simple example, chat GPT. Okay, or Google Bart is also there. Okay, this is based on some image based, we can say the image based, right? Now what is the agent? Next trends, AI agent. What is AI agent? AI agent is doing the one task. AI agent is doing the one task which is one to one, like as one agent is there, I am doing one task to him and he is giving the reply, like as a AI agent, like as a program, it takes the inputs and think and act to complete a task using some tools, right? Like as if I'm asking my machine to book a ticket from Pune to Delhi. Okay, agent can think, search, use the tools, okay, and book my tickets, right? So this is the AI agent. What is the agentic AI? What is agentic AI? Here, one agent is there only. One agent is there. In agentic AI, many agents are there, like as one or many AI agents works automatically on long task, making decision using the tools, like as if I want to say I want to go to Delhi and also I want to visit the nearby tourist places, like as I want to visit the Agra. So schedule, okay, book my hotels and also book the return tickets, which is less than 10,000. So for 7 days, 7 days, one agent is not capable. We need to use the different tools. Like as one tool is asking about the make metric. One tool is handling. One agent is handling for the some tourist places. One is handling for the prices of the hotels. Right. Multiple agents are there. Right. So is it the new era in the AI where they are using, they are handling automatically many things, right? Like as if I'm saying I am writing the codes, and when I write the codes, I say my machine, I don't have a time now, run my codes. If error is there, solve these errors, and again train my programs and give me the output. Tomorrow I will see my outputs. Definitely this agentic AI is doing. So this is the new era. This is the new era in the market where agentic AI is also some importance. As a summary, just I want to give you the some reference, and where from where we can start. First important thing is, for if you want to understand the transformer, you must read the Attention is All You Need paper, which is freely available. Many sources are available on the net, like as the blog is also there. Okay, blog is also there. The some references are there. You can start with the journey, but remember, we start our journey with simple neural networks, then multi-layer perceptron, then CNN, then RNN, then LSTM, and then transformer. Now remaining some parts. Okay, I can't cover all this thing in one session, but remaining some experts can cover the remaining parts, like as already I saw your schedule. Tomorrow you can see the fine tuning or the pre-trained models, right? So here my role is end. Now if you have any uh, queries, you can ask, or I already share my mail ID to the organizers, or I can show you my uh, mail ID on the screen. If you have any queries, you can put the queries on my mail ID. Now, some time for you. If you have any queries, you can unmute and you can ask.
All the participants, if you have any queries, you can drop in the chat box, or you can unmute yourself. I've enabled the settings now. You can unmute yourself and ask. So you can share the material with me. Everyone is asking for the material. I'll upload it on some drive and share it to all the participants.
Okay, ma'am, sure.
Anyone with any query? So there was one query. What is the best example to explain ANN to students? Students get bored or can't remember the whole concept. So what could be the real life analogy to introduce the concept?
Which CNN?
Sir, ANN.
ANN.
Entire.
Ma'am,
Yeah.
artificial neural network. Actually, ma'am, root of this all techniques is artificial neural networks. The best book is Zurada, Artificial Neural Network by the Zurada. Okay, if students, you can suggest this book to the students. If students are reading this first chapter, first three chapter, definitely they will clear all the concept which I covered in this session, like as a single layer perceptron, learning rule, okay, forward pass and backward pass. And one very good ebook is also there, like as a neural network and deep learning.com. So you can also refer that one. Many basic papers are there. You can start with the artificial neural network by the Zurada for your question. Answer is there.
Okay, one more question. Is there any research area security in LLM?
Yes, definitely. Another upcoming trend is the security. If, for example, I am using the transformer-based AI techniques in my bank, right? So sometimes security concern is also there. So definitely you can suggest some areas where you can use the pre-trained models and protect our data like that. Actually, I don't know the exact title in security. My area is image. Okay, so I can't suggest you the some titles, but question answer for your question is yes, definitely we can.
Okay, so let's conclude our today's program.
Okay, if no question is there, then thank you organizing committee, and thank you Sandeep Kadam sir for giving me the opportunity to share my knowledge with all the participants, and I hope all participants should use this concept for their research. Thank you very much.
Yeah.
Shall I remove, sir? Shall I end or shall I?
Just a minute, sir.
With this, thank you all for your enthusiastic participation. We look forward to welcoming you back tomorrow at 2 p.m. for day 2 of the program. Thank you.